We're currently recorded. Tapos I'm going to share the PowerPoint again. Okay. So next, we're going to drag naman pala to. I-drag nyo lang yung camera, ano, kung saan nyo pwedeng ilagay para makita nyo yung PowerPoint. So we're going to discuss the concept of D critical. Okay, this is, remember D is the dilution rate. So this is D critical is the critical dilution rate. So we have here a diagram, ano? Yung Y is concentration of S or concentration of X. Bali, concentration of the substrate or concentration of the biomass in grams per liter. No, yun namang X is, this is the dilution rate. So ito yung F over B. B is the volume, F is the feed rate, no? Feed volumetric flow rate. So as you can see, if you're going to increase the dilution rate, kung marami kayong pumapasok na substrate, syempre ang mangyayari as you increase the input ng substrate, ano, tumataas yung dilution rate. Syempre yung productivity tumataas. Dumadami yung ang definition dito ng productivity is RG to, ano, parang yes, this is RG. Productivity is RG. This is parang mu times D, no, or dx. This is dx, productivity. Ito yung rate ng increase ng production ng ng cell, ano. Ito yung productivity. So generally, as you increase the dilution rate, tumataas yung productivity kasi mas maraming kinakain yung bacteria, no, na halimbawa na sucrose o kaya glucose, di ba, gano'n, di ba, pag halimbawa sa bahay nyo, marami kayong pagkain, di ba, mas mabilis kayong lumaki. Ganun lamang yan, ano? Pero meron kasing tinatawag na na critical dilution rate, ano? Pag kasi remember we're using a CSTR. So kung ano yung pumapasok na flow rate, yun din yung lumalabas kasi nga steady state. So kung minsan pag masyado nang malakas yung flow rate na pumapasok, tapos masyado na ring malakas yung output, no? Kasi equal lang yung dalawa, di ba? Pag nilakasan mo yung input, lalakas din yung output. So ang mangyayari diyan, if you will imagine, yung production ng microorganism, hindi siya makahabol dun sa output, dun sa lumalabas. So ang mangyayari, mawawash out, no? So pag na-wash out, yung concentration ng bacteria dun mismo sa CSTR, dun sa fermentation tank natin, magiging zero, mauubos yung bacteria. So as you can see, pag naubos yung bacteria, syempre, magiging zero na rin. Pag wala nang kakain nung kahit maraming ka pang substrate, maraming pagkain, kung wala nang kakain, wala ka nang palalakihin doon, di ba? Wala ka nang padadamihin. So magsisiro yun. So ang tawag doon is the D critical, the critical dilution rate, no? And this is still equal to U max SO divided by KS plus SO. Ganun pa rin yung equation niyan. Kasi D pa rin naman yan eh. Okay? So I hope you get this. So ang practical importance nito, you can only increase the dilution rate up to a certain point. No? Kumbaga kamukha nitong sa graph. Halimbawa, D critical mo dito 0.5. Hindi ka pwedeng mag-increase ng D critical mo beyond 0.5. Later, we're going to have a optimum D equation. So pag na-calculate yung D optimum is beyond the D critical, hindi pwede yon, hindi nyo pwedeng i-apply yon. Dapat andito lang siya, mas mababa siya sa D critical. Okay? So I hope you get this idea, no? Na hindi nyo pwedeng increase yung flow rate, no? Without bounds, no? So pag inimagine nyo kasi, pag malakas yung flow rate, papasok dun sa fermentor, mauubos yung microorganism, mawawash out. Okay? Okay. Sunod naman is yung productivity. So productivity is dx, ano? This is mu times x. So as you can see, this is a plot of k sub s. Remember k sub s, this is the monod constant, ano? This is a plot of k sub s against dilution rate on x and productivity dx on y. So as you can see, siyempre mas gusto natin mas mataas yung dx, di ba? Gusto natin maximum yung productivity natin. So as you can see, for every ks, okay, for every ks, meron tayong optimum dilution rate. Iba-iba yung optimum dilution rate. For example, pag 0.64, ito yung kanyang optimum dilution rate. Pag 0.32 na lang yung ks natin, ito yung kanyang optimum dilution rate. So merong experimentally nakita nila merong optimum dilution rate. So si Colson, I'm getting all this from Colson, ano? So si Colson, dinerive niya yung optimum dilution rate. So ito yung equation natin ng optimum dilution rate. Sa board exam, kailangan tandaan nyo to. Ano? So this is how you calculate the optimum dilution rate. Yung derivation niya, so basically as you can see from here, inequate lang niya sa zero yung derivative ng dx. So ano, ito yung dx equation. So tapos inequate niya sa zero yung derivative. Tapos ito na yung equation natin after equating that to zero. And tapos in-isolate niya yung d optimum, and then we have this as our equation for d optimum. So kayo na lang bahala diyan, ano, medyo mahaba siyang i-solve. So gagamitin na lang natin tong equation ng d optimum in our problems, no? So let's try a problem. So ito muna ang problem natin. Okay. So we're going to first we're going to evaluate monod kinetics. Kumbaga, we were trying to solve U max at saka yung K sub S. So halimbawa, meron tayong data. We have sets of data. So tingnan natin kung paano natin iso-solve yung U max at saka yung mu S, no? So we have a chemostat study was performed with yeast. The medium flow rate was varied and the steady state concentration of cells and glucose in the fermenter were measured and recorded. The inlet concentration of glucose was set at 100 grams per liter. Ito yung SO, ano? Or CSO, 100. The volume of the fermenter contents was 500 ml. The inlet stream was sterile, ano? Wala siyang bacteria. X is equals to 0. So find the rate equation for cell growth. So ang rate equation for cell growth yung Rg to, ano? So Rg is equals to mu times x. Okay? Ganun lang yan. So kailangan na lang natin for first requirement, so solve lang natin yung U max at saka yung US. Okay? And then what should be the range of the flow rate to prevent the washout of the cells? No? Okay, so let's examine the given. We have flow rate in ml per hour. Tapos ito yung Cx niya, ito yung concentration na lumalabas sa sa CSTR. So pag 31 ang lumalabas na Cx, concentration ng cell ay 5.97. Tapos yung substrate concentration ay 0.5 and so on, ano? So and then as you can see, pag ang flow rate niya 200, yung cell concentration niya Cx ay 0. So ito yung D critical niya, 200. So dapat hindi ka lalampas ng 200 kasi mauubos yung cell. Yung yeast mauubos, no? So pag ganyan, kung ano yung pumasok, yun din yung lumalabas, 100, di ba? Pumasok natin ay 100. So hindi na nakakain yung yung substrate, di ba? Basically siguro na-imagine niyo naman kung paano to iso-solve, ano? Siguro dito na lang tayo para kita niyo yung data imbes na mag-whiteboard tayo. Regression lang naman to, linear regression lang. Kasi 'di ba ang equation natin ay F divided by B. Yung B natin is volume, ito yung feed flow rate, Tapos this is equals to U max times S or CS. Ito kasi CS yung nandito. Tapos KS plus C sub S. So, ang gagawin natin, kunin natin yung reciprocal para maging linear equation. So, pag kinuha niyo yung reciprocal, you will have B over F is equals to KS plus C sub S divided by mu max times C sub S. Yun. So, pag ganito na siya, siguro isang modification pa. No? So, you're going to B over F, isang simplification pa. B over F is equals to KS mu max times 1 over C sub S. Tama, no? Plus 1 over mu max. Can you follow? So, yun, linear na siya. Ito ang X natin. Tapos, this will be, ito yung magiging Y. So, yun, palagi naman tayong gumagawa ng ganito. Ano? So, probably alam niyo na kung ano yung gagawin. So, parang ang gagawin lang dito, yung X, halimbawa, ito yung X natin, 1 over CS. So, halimbawa, 1 over 0.5. Tapos, susunod, 1 over 1. Tapos, huwag nyo na isasama to kasi mag-iiba yung makukuha yung slope. Usually, hindi na yan linear with the other data. Eh. So, huwag nyo na isasama yung last data. Yung sa, tawag dito. Yung sa D-critical, huwag nyo na isasama. So, hanggang 4 lang, ano? Tapos, yun namang, tuloy nyo lang ito, 1, 2, 3. Tapos, yun namang, Y, yung Y is B over F. So, ang B natin is 500 ml. Kaya na lang unit analysis, di na kasi kasya. Tapos, di-divide nyo lang ito ng 31. Tapos susunod, 500, di-divide nyo ng 50. And so on. Okay? So, makakakuha kayo ng y-intercept. Tapos yung y-intercept natin na equal sa ito, 1 over mu max. So, halimbawa, ang y-intercept ay equal sa 3.98, no? So, paki-double check na lang kung tama yung nakuha ko. So, ang Umax, it follows that Umax is around 0.25. No? Ganun lamang. Tapos, susunod, yung B, yung slope. Yung slope naman ay equal siya dito. Ano? K sub S divided by mu max. So, if this is equal to 6.07, so it follows that K sub S is equal to 1.52. Ano? This is in grams per liter. Ang K sub S palaging pareha siya ng unit ng C sub S. So 1.52 yung tapos ang mu max natin ay 0.25. Okay. So find the rate equation for the cell growth. I think that is RG, RG lang 'yan. So ang RG natin ay palaging mu x. So 'di ba ito 'yon Ito yung ating mu max. Ang mu max natin ay 0.25. Okay, so probably you have RG is equals to 0.25 times C sub S, tapos K sub S natin is 1.52 plus C sub S, tapos times C sub X. So ito yung sagot dito. Do you have any question regarding the rate of the cell growth? Okay lang? Tapos, what should be the range of the flow rate to prevent washout of the cell? So ano sagot dito? Sa pangalawang tanong. It should be below 200 ml per hour. So ito, ang sagot naman dito is, it should be less than 200 ml per hour. Question. Do you have any question regarding this problem? Wala? Okay lang? Okay, so kung wala, let's proceed. Okay? I think this would be the last problem for today. Tapos I'm going to leave you with an exercise. So yung ating midterm hanggang dito, ano? Hanggang dito sa problem na to. So when a continuous culture is fed with substrate concentration of 1 gram per liter, the critical dilution rate for washout is 0.2857. Remember the critical dilution rate? Ito yung maximum, ano? Ito yung maximum na pwede. Otherwise, mawawash out yung yung microorganism. This changes to 0.95 per hour if the same organism is used, but the feed concentration is 3 grams per liter. Yung 1 grams per liter at yung 3 grams per liter, yan yung initial feed concentration. Ano? Calculate the effluent substrate concentration. Okay? When in each case, the fermenter is operated at its maximum productivity. Okay, you need to find the final effluent kasi, di ba? The final substrate concentration. So basically, S yung pinapahanap dito sa problem na to. Ano? This is from Colson. So ang ating Ks is 0.0496. Tapos yung Umax natin ay 0.3 per hour. How do we solve this problem? So this particular problem, ang gagawin natin, isosolve lang natin yung the optimum. Kasi ang tinatanong niya is at its maximum productivity. So you need to solve the optimum. Tapos pag na-solve niyo na yung the optimum, gamitin niyo lamang yun dun sa monod equation. Di ba yung monod equation natin is d or mu is equals to u max times s divided by k sub s plus s. So meron naman tayong k sub s, meron din tayong u max. Ganun lang. Ano? Okay. So let's try to solve the optimum. So gamitin nyo lamang yung equation kay Colson. Let me double check. It's the optimum is equals to mu m or mu max, okay, times 1 minus square root of k sub s divided by k sub s plus s sub o. Okay? Ganun lang. So just substitute the given, 0.3 per hour. So ito yung magiging unit niya, ano? Tapos times 1 minus square root of k sub s, 0.0496. Tapos all over 0.0496. Ito yun, di ba? Ito yung k sub s natin. Tapos plus yung initial flow rate. Yung sa unang case, it's 1 gram per liter. So parehas lang naman sila ng unit, ano? Parehas lang, double check the units, ha? Parehas lang naman silang grams per liter. So they are compatible. So plus 1. Okay? And then try to solve the optimum using your calculator. So the optimum, you're supposed to get something like 0.2348. Ay, sorry. So, ang unit nito, kung ano yung unit ng mu m nyo, ano? So, per hour. Yan, ganyan lang. Okay. So, ang gagawin nyo dito, i-compare nyo sa given na D-critical. Ang given na D-critical is 0.2857. No? So, since this is less than 0.2857, ito yung D-critical. D-critical. You can use this value. No? Pwede mong gamitin yung optimum dilution rate. So, the second part of the solution is to use the monod equation. So, the monod equation is D optimum is equal to mu max times S. Ito yung tinatanong, yung S na yan. Tapos KS plus S. Substitute mo lang, 0.2348. Mu M is 0.3. Tapos times S. Okay? So, divided by K sub S, 0.0496 plus S. And then try to solve for S. Ano? So, you're supposed to get something like, for the first set of data, you're supposed to get S is equals to ano? 0.1786. Okay? Grams per liter. Ito yung final answer. Ano? Nakasundan ba? So basically, isosolve nyo lang yung D optimum. Tapos pag nasolve nyo na yung D optimum, compare nyo dun sa given na D critical. Dapat mas mababa siya. Kung hindi siya mas mababa, syempre, wala na kayo. Hindi nyo na malala. Ang maximum na lang dyan, siguro, the best thing that you can do is probably choose a number below this one. You know? And I mean, walang solution yan. Pag lumampas siya ng D critical, yung D optimum niya. Tapos yun, if you have this, just use our basic equation for chemostat. Ano? Substitute dito, and then solve for S. Yun yung tinatanong. Okay, so do you have any question for this problem? Yung second set, halimbawa yung pangalawa, yung 3 grams per liter. So, yun yung nasa ano nyo, nasa BBL. Okay? So, pakisolve yan. And we're going to continue we're going to have another Zoom session next week, no? Sa 24. Pero I'm going to post your midterm soon, no? Maybe tomorrow or ano ba tomorrow? Thursday or Friday, ano? Pero sige, ilalagay ko lang deadline nun siguro sa 25 na, ano? Ang finals natin is after the 25th ata. So do you have any question? You have a Chemostat 2 exercise waiting for you in BBL. Questions? Okay, kung walang question, so I guess, naintindihan niyo naman, madali lang naman, ano? So, I'll stop the recording.